Welcome. In this video, we're going to do a hands-on tutorial with the AWS Management Console to create a DynamoDB database. This isn't intended to be a theory lecture or video, but and I will create a separate video covering the theory of DynamoDB. However, I'll give you some basic theory as we go along. Just at a very high level, DynamoDB is a NoSQL database. It's entirely hosted by AWS. You don't need to worry about the back end of how it's working, so you're not managing the actual infrastructure itself. You're not worrying about disk space. You're not worrying about CPU. You're not worrying about any of that side of things. Uh, it has very low latency in the milliseconds. The data is well, the default usually is it is eventual consistency. We'll talk about that a little bit later on. There is a strong consistency option. Uh, and Also, it's worthwhile noting that your data is stored across multiple availability zones within a region and on different partitions. So this means that it is highly available too. Reasonably tolerant in that regard. So to create a DynamoDB database, you just search for it in the management console and click on DynamoDB, and this will bring you to the landing page. Landing page, click Create Table, and then it will prompt you for the table name. So the table name in the example we're going to do here is going to be books, and then you must choose a primary key. Now, the primary key can be comprised of just the partition key, or a combination of the partition key and the sort key. So if you just had a partition key only, so your values are going to need to be, partition keys are going to need to be unique. So if we were to have author as a partition key, and we would have no sort key, this would mean we can only have one author um, uh, per item, basically, or each item would have to have a unique author. Sorry, put another way, you can have two items with the same author because it's a partition key, and the partition key needs to be unique. What you'll find is most common is people have a sort key as well. So we have author as a partition key, and the sort key will be title. This means that the primary key is a combination of the title and the author, which means that you can have any number of books you like from a given author, as long as you don't have two books with the same title, or as basically the what we'll do is we'll play around with that a little bit more once we've created the table. But it's important to note that this is the information you need to set up when you create the table and can't change it later on. Table settings, there are a bunch of settings here. You can use the defaults or you can specify them. So we'll leave secondary indexes off this video. We'll do a separate video looking at that, but we will look at the other options here. So your read and write capacity needs to be selected. So you can just do it on demand, and this is where the AWS handles the read and write capacity of your table effectively transparently to you. Or you can do provisioned. And under provisioned, you have to specify either specify the read capacity units and write capacity units, or they can use auto scaling. So just as a background, a read capacity unit is basically in how many items you can read from your database. More specifically, one read capacity unit allows you to read two items of up to 4 kilobytes per second. So you could read two 4 kilobyte items per second with one read capacity unit, or you could read four 4 capacity units, four 4 kilobyte items with two read capacity units. We'll go into this a little bit more on the theory side of it, but it's important to note that there is another option when you're doing reads, and that is for strong consistency. Strong consistency means that you actually you have half the actual capacity. So instead of being able to read two 4 kilobyte items per second with a read capacity unit, When you're doing strongly consistent, you can only read one item of up to 4 kilobytes with a read capacity unit. Uh, so effectively strong consistency uh, does cost you. It's basically twice as expensive from a read capacity unit point of view. Uh, and it really depends on whether your application requires strong consistency or not when you're designing it. But you may find that something like banking transactions need strong consistency. Otherwise, you might be able to transfer, money out of your account and then quickly read the database again, and because it's eventually consistent, you'll find that the value you receive has not been updated, and it would reflect the wrong value. But really, writes generally happen in under a second, so it's not really uh, highly likely that you will read a older piece of data. Um, the it is possible, but it's basically going to synchronize pretty quickly. Um, write capacity units basically is pretty straightforward. It's one write capacity unit lets you write one item of 1 kilobyte. If you're writing one item that's 4 kilobytes, it's going to take 4 write capacity units, uh, and so that's pretty straightforward. Um, Generally, DynamoDB is best for read heavy applications, not write heavy. It does give you a cost estimate here of the estimated cost per month. Um, Now, you do have the option of using auto scaling. So with auto scaling, you can set a threshold, and basically you have a minimum and maximum number of read capacity units, and you have a utilization threshold, which means that when you trigger this threshold and you're using, say, more than 30, 70% of your read capacity units, AWS will increase the number of read capacity units. And then it will also scale back as your utilization drops off. Um, so your maximum read capacity units and minimum can be specified. And these are independent for read and write. So you might find your application is very read intensive, which is really the ideal for DynamoDB, um, and in which case you may have very few write capacity units. But you may also find that you have an application that is more write heavy, in which case you may want to scale that differently and then allow for more write capacity units. You also have the option of making the settings identical. Because we're doing a demo only, we're going to manually specify this to just have one read and one write capacity unit. Uh, Obviously, it's going to limit our database, but given that we're doing this from the console, we're not expecting a lot of traffic. Uh, Now, there is an option for encryption at rest. You can leave this as a default where the DynamoDB or Amazon handle the keys for you for encryption at rest, or otherwise there's a customer or AWS managed key option. And finally, there's also tags. This is common across most AWS services. You can have a tag of something like environment, and it could be the test environment, and that just makes it easy later on to work out what's production and what's test. You might want to label production items as environment prod, for example. Um, right. So once you click create, your database will be created, and it'll take a second for this to happen. Typically not so long actually, and this will give you an overview. So we have a table name of books. Its primary partition key is author, and the sort key is title. We have only one read capacity unit and one write capacity unit, and there's no auto scaling. And currently we're using 0 byte with 0 items. We're in Singapore region. This gives us the resource name, um, and that's pretty straightforward. The What we'll do is we're going to look at the items in the database, and we have none, unsurprisingly. So we want to create some items. So we create some items here. We're going to create a book and call by Tom, and it's going to be called book 1. Click save, and then we create another item from Tom, and we're going to call it uh, title. We're going to call it book 2. Click save. Now, just to demonstrate, we can't create another item with the same exact author and title combination. So we can't create another item from book from Tom called book 1. Book 1, because it will throw an error. Basically, it has to be unique, the combination of author and title. You may, however, need to be aware, well, you need to be aware that that is case sensitive. So you could create a name of another item with the same author and title, but using different case, and hey presto, you've got book one. So it is important that you remember that the case sensitivity of DynamoDB, uh, and this also applies for searching too. You know, you're going to want to ensure that uh, you write your searches in a way, your queries in a way that to and store your data in a way that you can take into account the case sensitivity. We're going to delete that. We can delete that item. Actions, delete, delete that item. That's gone. Create a few more items. We're going to create a book by Jane, and it's called My First Book, and then we can create another one by Jane. Maybe My Second Book, and again click Save. So now we've got basically 4 items in our database. The you know, 2 different authors, different titles. So why don't we have a look at doing some searching or scanning and querying of the database. So the most efficient way to query or scan or search your database is by using a query. In a query, you actually have to specify the partition key. So this means that we're going to have to always search by a specific author, and that may not be ideal if you want to do a search where you knew the title but not the author. But this is a requirement when you're doing a query. You must specify the partition key. If you leave it off and you specify only the sort key and say book 2, click search, it's going to fail. It will tell you here you have to have to enter a value of the partition key. So we have to say Tom, but we can leave the sort key blank. Click search, and here we got the 2 books from Tom. We can do a sort key of the book name, book 2, say equals book 2. That's fine. And we'll also say begins with. So we do begins with book, and find all the titles by Tom which begin with the word book. And then the other option, so basically the reason before I go on is that this is efficient is because of the way that the Amazon stores the data. It's essentially breaking your data into different partitions and storing that data accordingly. So by specifying the partition key, it can find that data very quickly, and the data is actually stored, I understand, in order of the actual sort. So it's very quick for it to go through the database and find the find the data that you're looking for based on a partition key and a sort key. If you want to do a less efficient key, you can do a scan, and and what we'll do in order to demonstrate that, we're going to add some additional data here to this. So we're going to click on this, and we click on Jane, and we're going to append a string, and we're going to say year, and that's 2000. You can see that we've added an additional item. Now this is key value pairs, so you can add whatever item you want. You could add an item which is perhaps publisher, and that can be the XYZ company, and you can say, and as you can see, it's just there. Essentially, you're completely free to do whatever you want. There's no fixed schema, being a NoSQL database. But what we want to do for the purposes of searching is we want to edit those values. So we're going to add we're going to add a year, and we have 2001. Click save, and then we're going to have Tom, and we're going to add some information here. Now you might be wondering, well, what's the difference if I append or insert? Well, if you insert, it's going to go before the item, and if you append, it's going to go at the end. It doesn't really matter. You click remove, for example. You can click append string year, and that's going to be 2020. Click save, for example, and then we're going to have book 2, strangely going to be written before book 1, but we'll append, add it to the end, and year and 2000. So here we go. So now we have our data with the partition key is the author, the sort key is the title. So that allowing us to search very efficiently for those items. So if we, go back to a query and we want to search for books from Tom that begins with the word book, we click search book, and then, but we can also add a filter. So now we can say we want the year to be equal 2000. Click start search, and now it's going to very efficiently search for the partition key and sort key and return the results, which was the two items by Tom, book 1 and book 2. And then what AWS is doing, or DynamoDB is doing, is it's filtering those results for the year. This isn't as efficient, but it is the efficiency you're getting is because you're getting at reasonably low cost from a search point of view. The item based on the partition and sort key, and then just narrowing it down further from the filter. Um, if you were to not specify the sort key, so actually we won't do that. What we'll do is we'll show you the scan first. So we can go back to scan, start search. Okay, right. So the scan, we can basically do filter whatever we want with a scan, and the scan is not efficient search. It's basically going to go through the whole database looking for this information. So if we want to look for all books of the year published in the year equals 2000, we can search, or we could and you know, for example, the publisher equals XYZ. We want to delete that one. XYZ is the publisher. So there you go. You can search for publisher. You have as many filter items as you want to. So I should say that if you wanted to look for the title, contains the word contains my, then you're going to find, and you can remove the publisher. You can find all titles that begin with my, but you don't want to do that one with a scan because titles are all up as a sort key, and you could have done that with a query. But if you perhaps you wanted to provide all titles that contains the word book, which is actually all of our items, then this way you can search just based on the title. You're not searching by the author. It's not going to be an efficient search, but you could find all items. So from my experience with production uses of DynamoDB, if you're doing a scan, remembering which is an inefficient search of your database, and not leveraging the partition key and sort key, there is a noticeable difference in speed of searching. Whereas, because you're basically going through all the items, whereas if you do a query, it is significantly faster. And I've generally optimized for the normal searches that I do, but I have allowed for other searches in my application which use a scan, and they're more the corner case searches that end users might do. So in the end, that covers most things we want to talk about here. I would just highlight that you can check and modify the capacity. So you can increase the capacity units, read and write, or put back on auto scaling, or change it to on demand. There are some other options in here around indexes, which we won't get into today, global tables. There's the option for backup, so you can create a backup. So why do that? And this is books backup. Click create. Sorry. And that creates a backup. And there you go. These are backup. And then as an overview, you can go back to your table again. You can delete your table. Click delete table. And then you can optionally create a backup before deleting it. And when you delete the table, just type delete in the box, and the table's gone. So I will do a separate video where we look at the theory of DynamoDB, and we'll also have a look at creating a video to look at more detailed configuration options in the console. But that's basically all there is to it. It's pretty simple, and I encourage you to do some hands-on and have a bit of a play with it. It's pretty straightforward. Thanks for your time. Thanks for watching.